Lesson 38, Simple Inheritance. To follow along with this lesson, you will need to create a new console project and add a new file named main.cpp to it, as we did in Lesson 1. In our first program we have two classes, one class to create lights and one to create fans. Apart from the class names, these two classes are exactly the same. They both have functions to check whether the device is on and turn off functions to change the state of the variable is on. In our main function, we create an instance of a light and call turn on and turn off. In between these calls, we call the isOn function to output the Boolean value to indicate whether or not the light is on. The next set of lines does the same thing for a fan object. Executing the program, we see the values 0 and 1 outputted to indicate whether the devices are off or on respectively. In the previous program, we had two classes which contain the same code. This is both tedious to maintain and error-prone. Inheritance allows us to factor out common code into a commonly inherited base class. In this version, we have taken the member function code and variables out of the light and fan classes and put it into the class electric device. Now the base class electric device does all the work, and the light and fan classes inherit their functionality from the class electric device. Notice that the class names are now followed by a colon, the word public, and the name of the class that is being inherited. The important thing to realize is that we have replaced two copies of the same code with a single copy. The rest of the code remains the same, and if we execute the program, we see that it is functionally equivalent to the previous example. We remark that we can have many levels of inheritance. For example, here we have added a 3-speed fan class that inherits our fan class, which inherits our electric device class. The 3-speed fan class adds functionality for setting the speed of a fan via the member variable, and functions to get the speed and increase or decrease the speed. The 3-speed fan inherits all of the members of electric device from the fan class and adds functionality for handling the speed-related controls. In the main function, we have replaced the fan instantiation with an instantiation of a 3-speed fan. Then we use the same code to switch the fan off and on that we used before. However, we have also added code to increase and decrease the speed and output the speed to the console window. Executing the program, we get this. Our next program demonstrates how constructors and destructors are called through inheritance. Here we have a generic base class and derived class that inherits it. We have added output statements to the constructors and destructors of these classes for illustration. Notice that we have added a call to our base constructor from our derived constructor. We didn't do this in our previous examples because the default base class constructor is always called by default. Here we make the call explicit for clarification because many times we will want to call a different constructor for our base class, as we will see in our next example. If we execute this program, we see that the output shows the order that our constructors and destructors are called in. Notice that the base class is constructed first and destructed last. In our previous examples, we didn't include destructors. We don't need to include a destructor unless we need to do something when the object is destroyed. We only added destructors here for demonstration. In our final example, we have an owner class which simply contains a name string. Then we have a sellable item class which has an owner as a member variable. The sellable item class also has a price variable. Our third class is a car class which inherits sellable item. These three classes illustrate two fundamental relationships between classes, has-a and is-a. Every sellable item has an owner, and every car is a sellable item. When one class type has another class type, it is usually best to program the second class as a member of the first. When one class type is a more specific form of another class type, it is typically best to inherit the second class. An important feature of this last example is that the sellable item class has a constructor that takes arguments. In order to use this constructor in our car class, we call it from the car class's constructor here with our owner and price arguments. In the main function, we instantiate the owner class with zoax.net as the owner name. This owner is then passed into the constructor of our car object. Then we call the member functions to get and output the owner and price of the car. Executing the program, we see this. This concludes the lesson.